Calculate the integral of 2 over x squared plus 6x minus 7. So here we have to use the notion of partial fractions. For the denominator, we can see that the quadratic can be factorized into two separate parts. So we find two numbers that will multiply to give us -7 and add to give us 6, and that would be -1 and 7. Now we replace that into the equation and we find the partial fractions, which would be a over x minus 1 plus b over x plus 7. Okay, so we are going to work just with the numerators, which would be 2 equal to a times x plus 7 plus b into x minus 1. So if x is equal to 1, then a would be 1/4. And okay, so now we need to work out the value of b by substituting x equal to -7 so that it eliminates the a. That would give us 2 equal to 0 plus b times -7 minus 1 plus a 0. Hence b is -1/4. Okay, we can now substitute this into our original equation as partial fraction. So this will be the integral of 1/4 times 1 over x minus 1 minus 1/4 times 1 over x plus 7. So we substitute the denominators for u. Okay, if we let u be equal to x minus 1, du by dx is just the 1, and then the integral be natural log of x minus 1. And then for 1 over x plus 7, keep in mind we're going to have the same thing. So this will just be natural log of x plus 7. So our final answer would be 1/4 natural log of x minus 1 minus natural log of x plus 7. Keep in mind that absolute value is important. Then we simplify this using the rule of logarithms. This would be 1/4 natural log of x minus 1 over x plus 7. 5, we have the integral of x cubed plus 4x squared minus 2x minus 5 all over x squared minus 4x plus 4. So for this question, we need to use long division to simplify it because the degree in the numerator is greater than that in the denominator. So we're going to use long division to simplify. We'll take the dividend and divide by the divisor to get x. Then we multiply x by the divisor. We'll get x cubed minus 4x squared plus 4x. Then we are going to subtract our result from the dividend. And this would give us 8x squared minus 6x minus 5. Once again, we divide this by the divisor and we should get a positive 8. Then we multiply once again to get 8x squared minus 32x plus 32. And then once we subtract these two values, we should get 26x minus 37. So we go ahead and we substitute this into our original question, just like so. And then we can actually separate these two to have different denominators. Okay, the denominator for the last term can actually change to x minus 2 all squared using factorization. Now for the third term, which is 26x over x squared minus 4x plus 4, we notice that if we differentiate the bottom, we would have 2x. But then the numerator has 26x, so we can actually rewrite this such that it has a 2x in it, which would be 13 times 2, right? And then for the last term, we also have the denominator, which is x minus 2, having a derivative of just 1, which is a constant. So we can actually rewrite both of these fractions just like this, so that the second term would have an integral of 13 natural log of what is in the denominator, while the last term would have 37 times x minus 2 to the power minus 2 plus 1, all divided by minus 2 plus 1. Okay, This will give us our final answer, which is x squared over 2 plus 8x plus 13 natural log of x squared minus 4x plus 4 plus 37 over x minus 2. We have the integral of 1 over x squared plus 2x plus 10 dx. So we need to factor this quadratic expression in the denominator, right? We can use factor method by finding two numbers that will multiply gives us 10 and we add it gives us 2. 5 and 2. 5 and 2 does not work. Or we can use completing the square method, which might not really work. So we are going to use a different approach for this question. We're going to rewrite 10 as 1 plus 9. And then you can see that x squared plus 2x plus 1 is actually a separate quadratic which you can simplify using completing the square method as x plus 1 all squared, right? Now we would have two squares, x plus 1 all squared and 9. 9 can be rewritten as 3 squared, and then if I factorize out the 9, or let's say the 3 squared, it's going to be 9 into x plus 1 all over 3 all squared plus 1. Taking a look, we see that x plus 1 over 3, which is in the bracket, would have a derivative of 1, right? So I can let u be equal to that expression, so that du by dx equals to 1/3. Okay, now 3 du be equal to dx, and then we're going to replace this. So let's replace the u's first. If we replace the u's, we're going to have 1 over 3 u squared plus 1. Of course, 9 is divisible by 3, so you have to just cancel out. Okay, we have 1/3 u squared plus 1, and we can see that this is the integral of tan inverse of x, right? So we've looked at the integral in the previous question, so you can go back. So it means that this would be 1/3 tan inverse of u plus c, and if we replace u once again, it will be 1/3 tan inverse of x plus 1 over 3 plus c. Question 67, we have 2 over x minus 1 all squared times x squared plus 1 dx. Now